All right, these are the answers to page 399. The first ones here want us to find this equation of a tangent line to this point for this equation. So we have to take the derivative. So the derivative of natural log is 1 over whatever's inside of it times the derivative of what's inside of it. So derivative of 2 plus x is just 1, so we don't have to really include that. And then this over here, we've got to make a decision. So probably the best thing to do is to rewrite that as 2 times 2 plus x to the negative 1. And then this is kind of like a chain rule. We'll have that negative 1 come down. It'll give us a negative 2 times 2 plus x to the negative 2. So that's the derivative of the outer function. Then times the derivative of 2 plus x, which is just 1. All right? So this is our derivative. So now if we want to find the slope of the tangent line, we're going to put negative 1 in for x. It's going to give us 1 over 2 plus negative 1, so 1 over 1, which is 1, plus negative 2 over 2 plus negative 1, so that's 1 to the negative 2, which is 1. So we end up with 1 plus negative 2, which is negative 1. That's our slope of the tangent. So y minus y equals slope times x minus x. Should end up with that right there. So the derivative, 2 different ideas going on there. Plug the negative 1 in, solve. Similar idea here on 45. We're trying to find the equation of a tangent to this function. So we already have the point. So we're going to take the derivative. Derivative of natural log is 1 over whatever's inside of it times the derivative of what's inside of it. So the derivative of e is its own thing. Remember, we just do a repetition for the derivative of e times the derivative of the exponent, which is negative 2x. Something kind of weird happens here. These actually end up canceling out. And so we end up with the derivative is just negative 2x. Okay. We actually could have gotten that maybe even a little simpler if we had remembered our log rule. This exponent could have come down to multiply the natural log, and the natural log of e is 1. So this ends up becoming 1, and we end up, this function really is only negative x squared when you simplify it. The derivative of negative x squared, negative 2x. So one way or the other, we end up with this. Put 2 in. Our slope is going to be negative 4. And so y minus y equals slope times x minus x. There's our equation. For 46, we're taking the derivative of this. And we're going to have 1/2 derivative of e is its own thing. So we repeat sine 2 theta. Times the derivative of sine 2 theta. So that's a chain rule. Derivative of sine is cosine. Leave the 2 theta alone. Times the derivative of 2 theta, which is 2. Okay. This half and this 2 can cancel. Simplifies things a little bit. So when I go to find the slope now, the slope is going to be e to the sine 0. Sine of 0 is 0. Times the cosine of 0. Well, e to the 0 is 1. Cosine of 0 is 1. We get 1 times 1, which is 1. So that's our slope. So y minus 1/2 equals 1 times x minus 0. And we could simplify that if we want, but that's our equation right there. Then we get 48, and we're doing this implicitly. So for the first one, this is a chain rule. Derivative of cosine is negative sine. Leave the x squared alone. Times the derivative of x squared, which is 2x. Okay, so if another way of writing that would have been negative 2x sine x squared. We may do that on the next pass. This is a product rule. So the derivative of x is 1 times e to the y as is, plus x times the derivative of e to the y, which is e to the y repeated, times the derivative of that exponent, which is dy dx. All right, so this is what we want to get dy dx by itself. So I'm going to subtract this e to the y over. I'll go ahead and rewrite that as negative 2x sine x squared. That's this thing here, minus e to the y equals x e to the y times dy dx. Then we're going to divide by that. So we get this as our derivative, negative 2x sine x squared minus e to the y over x e to the y. And that's our derivative. Then 49 is looking for a definite integral. So when I look at this, I have e to a kind of a complicated exponent. So I'm thinking u sub, and the u is going to be that exponent. So I'm going to have negative 3x squared as the u. So du is equal to negative 6x dx, which means dx is equal to du over negative 6x. Okay, so I'm going to come back over here. We're going to have the integral of x e to the u times du over negative 6x. The x's drop. Okay, I'm going to be able to pull this negative 1/6 out in a second. But before I do that, let's address this. This 0 and this 1, these were x limits. But now we're going to be in terms of u, and we're going to want to stay in terms of u. So if I put 0 in for x, in here I get 0 for u. And if I put 1 in for x, I end up with negative 3 as the u. Okay, so there's my start and finish. So now I can do this. I'm going to pull this negative 1/6 out. The integral of e to the u du is just e to the u. We're doing that from 0 to negative 3. And so that's going to give us negative 1/6 times e to the negative 3 minus e to the 0. You do have to keep e to the 0 here because e to the 0 is 1, so it doesn't just go away. This can be our answer. We don't have to distribute or do anything else. This will be our answer right there. And then similarly on 92, this is going to be a u sub. I see this bottom 16 plus x squared. I think we'll just make that entire bottom the u. So du will be 2x dx, which means dx will be du over 2x. Okay, so come back over here. We're going to integrate x over u times du over 2x. The x's drop, which is what we want. We'll be able to pull that 1/2 out in a second. But again, these were x values. We want u values. So when x is 0, if I put that in, I get 16 plus 0, I get 16. That's the u value for that. If I put 4 in, I get 16 plus 16, that's 32 for that. Okay? So now we're going to stay here. We're not going to go back to x. We're going to just evaluate this right here. So that half comes out. We get the integral of 1 over u du from 16 to 32. And that's going to integrate to natural log u 16 to 32, which will give us 1/2 times natural log of 32 minus natural log 16. We're going top minus bottom. Now you can leave that, that's totally fine, or you can remember the log rule that says if you subtract 2 logs, you can make it one thing by dividing this by that. 32 divided by 16 is 2. If you wanted to get real crazy, you could bring the 1/2 up, make this 2 to the 1/2, which would be square root of 2. You could make it natural log of square root of 2. Either way, all of these are the same. All of them are good solutions.